All right, guys, here we go. We are going to do the last two rules for dealing with exponents. So we've already covered product rule, quotient rule, we've covered the power rule, and we've actually already covered one of the rules, which is the zero exponent rule. So I'm just going to talk about that really quick over here. Because most of what we're doing today is the negative exponent rule. All you have to remember as far as the zero exponent rule, and we've talked about this and we've talked about why, is that any non-zero number, so as long as a number does not equal zero, okay, the base cannot equal zero, but any non-zero number where the base or the variable is being raised to the zero power is always going to be equal to 1. And that's all you have to remember as far as the zero exponent rule. Okay? The base cannot be 0, and as long as that base is not 0, anything raised up to the 0 power is going to equal 1. And some of the videos I left for you all in this under today's date also go into that a little bit further. If you can't remember exactly why, you can also go back to our quotient rule if you need a little refresher on why that is also. Okay. What we're going to focus on today is mostly our negative exponent rule. So we've been seeing negative exponents with our integers, and as of now we've said just keep them as negatives. We haven't figured out what to do with them. Well, there is something that needs to be done whenever we have negative exponents. So that's what we're looking at today. So make sure you are following along and filling in your notes and pausing when it's appropriate to try some things out on your own. When an exponent is a negative number, we can think of it as taking the reciprocal. Now, the reciprocal fraction, if you remember from previous years, like if we had 1 over 2, the reciprocal would be 2 over 1. If we had a fraction like 3 over 4, then your reciprocal would be 4 over 3. So that is what the reciprocal means. So when we have an exponent with a negative number, we essentially are taking the reciprocal of that number. So in other words here, I'll zoom in a little bit so we can see a little more. In other words here, if we had x to the negative nth power, that equals 1 over x to the nth power. Here's another way to visualize what's happening when an exponent is negative. Okay, we have our base. I'm going to do some highlighting here so I can show you some stuff. Go back to that. Sorry. Sorry, I got a big old close-up picture of me for a moment. My bad. I can't even get to our highlighter. There it is. Okay, so there's my highlighter, and I just wanted to highlight, here's another way to visualize what happens when an exponent is negative. We always have our base, right? And that base, our base here is being raised up to a negative exponent. Let me change that color. Base is being raised up to that negative exponent. So let's just change that there. Ugh, how terrible. Try that again. Let's see if I can grab our highlighter. There's that color. Okay, so here's our base, and it's being raised up to a negative exponent. That's always going to be equal to 1 over the same base, but this time with the positive version of that exponent. We don't want to leave negative exponents in our solutions anymore, okay? So from here on out, we're done seeing negative exponents. We use all the rules, and then when we have a negative exponent at the end, we make sure we take care of that last. So we don't want to leave negative exponents in our solutions at all, okay? So we're going to use this rule, like I said, at the very end when we're simplifying our exponential expressions. Use this rule to help you write all solutions that have a negative exponent. So now we're going to look at some of this in action. We're going to look at what does it mean, like what did I just tell you, like what did all that stuff actually mean. Here we have a base, 4, and it's being raised up to a negative exponent or an integer exponent. So we have 4 to the negative second power, okay? Anytime we have a negative exponent, we take the reciprocal, and always the same thing happens. That's going to be equal to 1 over the same base, but with the positive of that exponent. Every single time we end up doing that, okay? So I'll show you this one more time, and I'm going to ask you guys to pause the video and do these two on your own, okay? So here's our base with our integer exponent. We have h to the negative 6th power. Our negative exponent rule says that any base raised up to a negative exponent, an integer exponent, is equal to 1 over that same base. So again, we're keeping our base here, but this time that base is raised to the positive of that exponent. So you see you have the same exponents here. The one in our original exponential form was negative. At the second one we have is a positive. Here's our original. We have a negative number, and then we end up with a positive. So essentially you're getting rid of the negative every time. Just because we see a negative exponent, it does not mean that we actually have a negative number. If you can see that these are still positive here, so that would not actually give us a negative number on the bottom, okay? So pause the video now, and I want you to complete number 3 and 4 on your own. You should have attempted this on your own, so we're going to go over it really quickly. We have 11 to the negative 7th power, so that is equal to 1 over 11 to the positive 7 power. For number 4, we have n to the negative 3rd power, and that is equal to 1 over n to the positive 3rd power. All right, that's what we do to negative exponents every single time. So, okay, so this word here that we're seeing is not something that I've asked you to do very much since we talked about exponents. When you see the word evaluate, that means you need to now turn that exponent into the standard form of that number. So we're going to simplify it to our exponential expression. That's already been done here, and then we have to turn it into standard form. So starting with number 5, we're going to take care of the negative exponent first. We have 8 to the negative 1st power, and that is equal to 1 over 8, but to the positive 1st power. That's your exponential form, and then we want to turn it into standard form. This one is pretty easy. In standard form, well, 8 to the 1st power is just 8. So in standard form, this one would still be 1 over 8 in standard form. Okay, but then we're going to see what it looks like a little bit more when we have a more substantial exponent. If we have 10 to the negative 4th power, we have 1 over 10 to the positive 4th power. That's your exponential form, but we want to take that out to standard form. So 10 to the 4th power, what does that mean? Well, without the 1, we would still know that 10 to the 4th power is just 10 times 10 times 10 times 10. 10 times 10 is 100. 100 times 10 is 1,000. 1,000 times 10 is 10,000. So 1 over 10 to the 4th power in standard form would be 1 over 10,000. All right, so you're going to pause the video here, and you're going to try your hand at taking number 7 and number 8 and putting them first into exponential form and then into standard form. Try it. You guys should have already attempted number 7 and number 8 on your own, so we're just checking those. 7 to the negative 7th power, 7 to the negative 2nd power is equal to 7, messed that up already. Let me erase that. 7 to the negative 2nd power is equal to 1 over 7 to the positive 2nd power. That's your exponential form. And then in standard form, we of course know that 7 squared is just 7 times 7. So in exponential form here, we would have 1 over 7 times 7, which is 49. That's your standard form. Number 8, we have 2 to the negative 3rd power. That is equal to 1 over 2 to the positive 3rd power. That's your exponential form. We know that 2 to the 3rd power, 2 cubed is 2 times 2 times 2. So your standard form is going to be 2 times 2 is 4, 4 times 2 is 8, 1 over 8. That is turning your exponential form into standard form when you have those negative exponents. Pardon the glitch that just happened with the screen. I didn't want to have to start my video over, so we're going to start off from here. Okay, so we have 2 more problems left. We are using the laws of exponents now to simplify the problems, and we're going to leave our solution as a value raised to a power, and we're going to make sure we use it as a positive exponent. This is important because this means we are now using, all of our exponent rules. Okay, so that means we are now going to take all of our rules, all the laws we've studied, and we're going to do that to simplify the problem. When it says we're going to leave our solution as a value of a raised power, that means we need to leave it in exponential form, and to be sure to use a positive exponent, that means at the very end when we are done using our other exponential rules, then we are going to use our negative exponent rule. All right, so for number 9, first thing we have to take care of, negative exponents always comes last in this process. So we're going to look at what other rules are needed. This is 6 to the 3rd raised to the negative 2nd power. That means we have 6 to the 3rd raised up to the negative 2nd power. That's your power rule. And the power rule tells you that you're going to keep the base and you are going to multiply your exponents. So if that's what we're doing here, and it is, our base is going to be 6 still. 3 times negative 2 is negative 6. So now we have an integer exponent, and we have to take care of that using our exponent rule. And we just learned that any non-zero number raised up to a negative exponent is equal to 1 over that same base, but this time with the positive exponent. So we would have 1 over 6 to the positive 6th power. Go ahead and pause the video and attempt number 10 on your own. Okay, so you should have already tried number 10. We're going to go about it together. We have 5 to the negative 4th power, and that's divided by 5 to the 3rd. This is our quotient rule, and our quotient rule tells us that we are going to keep our base and we are going to subtract our exponents. And this is negative. Remember, we learned a different rule, a little integer rule, a strategy to help us handle those those integer rules. Anytime we're subtracting integers, we add the opposite, which means we change the addition sign to a positive sign and we change the sign of our second number. So then we can actually see we have only one rule, which is negative 4 plus negative 3, which ends up being negative 7. So we have 5 to the negative 7th power, and our negative exponent rule tells us that that ends up being equal to 1 over the same base, our 5, but with the positive of that exponent. All right, guys, that is it. take this and do your practice. If you're still unsure, I have several videos that I've uploaded for you that can help you to clarify this process. Send me questions if you have them.